If you are coming in after school anytime this week, make sure that you come in on Wednesdays. Okay. I've got sports starting up. Oh, Tuesday, Thursday is a little taken up. If you need specific tutoring, there are other teachers available as well. We're going to utilize Pride time. If you can come to me during Pride or Lion time or whatever, and you need to knock out a test, just let me know. I'm okay with it. If your teacher is okay with it for Pride, if you need a pass, just let me know and I'll write one. Okay. So today we're going to have our quiz over 4.1 and 4.2. So let's go ahead and start reviewing for that. Okay. So on here, it says that Jerry has two financing options. 325 monthly payments for 8 years, or 25 monthly payments for 6 years. Which option costs the least amount after the final payment has been made? All right. So let's think about this really quick. If they're doing 325 a month, how many months are in a year? Okay. And then how many years is this person doing? Okay. How much is that in total? So words again. 31,200. Okay. Down here we got 425. There's 12 months in a year, and we're multiplying it by 6. What do you get? Okay. Now, the question asks which option costs the least amount of money after the final payment has been made. So yeah. It doesn't have a rate. If you wanted to plug in and do simple rate or a simple interest, you can do it that way as well. That's okay. Okay, so ready? You can use simple interest and you can find the interest and compare. Yes. Or you can just do, hey, this is how much it's going to be. It's going to give you the same result. Did you get option 2? Okay, we're good. Yes. All right, option 2 has the least amount. Okay. Good. Questions? All right, next one. You want to purchase a car for $35,990. Have two financing options. 4.5% APR for 5 years compounded annually. And then if it'll scroll down. No. Okay. 3.5% APR for 6 years compounded annually. This is the one where you're going to go into Desmos. You're going to type in the formula and then you're going to go from there. So really quick, you've got 35,900. That's your principal amount. 0.045 is your rate. It's monthly. So T is 5 and N is going to be 12. A lot of us are mixing up N and T. N is the number of times it happens in the year. T is how many years. Does that make sense? So we're going to go in here, go to Desmos, type it in. 1. If you're not typing in Desmos, shameful. Do better. Shameful. It is a long formula. All right, check my work because I just typed that really quick and by memory, so there ain't no telling. I got 669.28. First of all, on this one, 900, not 950. Ah, thank you. 670.96. Okay, so that's how much it was for the monthly payment, right? 670.96. And we're doing monthly and we're doing it for 5 years, right? So we're going to come back in here. We're going to say 670.96 times 12 times 5. Total is 40,257.60, right? Good. Now we're going to do option 2. It's the same thing except our percent is now 0.035, and our years are 6. So when we come back in here, we're going to say 0.035, and our years are 6. And that gives me a monthly payment of $554.91. So I'm going to come down here, 554.91, and we're doing it for 6 years, right? So that's going to be 39,953.52. What was our quote? Yep. Because it says 6 years. I'm finding my total. The question asked me to find after the final payment. Right. So what we put in Desmos was a monthly payment, and then you're doing it for all of the years. Yeah, babe. You are correct. So what would our N be? Thank you for catching that. So really quick, they paid attention to the fact that it said annually, not monthly, right? So that changes our N to be 1 and not 12. Okay, so on this one, this is option 2. Okay, on option 2, you're going to have 6,754.18. Okay. And then what are we going to do to find the final payment? Like how much is going to be after the final payment? Multiply by what? 6 years. So we're going to multiply by 6 years. Okay. N is 1 because annually. Yep. Thank you. Yes. Ladies and gentlemen, you need to make sure that you pay attention to whether it says annually or it says monthly. Okay, it says annually. That means our N is going to be 1. We're still going to plug it into this formula. So if we were looking at option 1, we would plug this in. We would say 5 years. We would say 4.5%. Okay, this is how much you would pay annually. How would we figure out how much we pay in total? Multiply by what? Why are we multiplying by 5? Because it's for 5 years. Okay, so for option 1, we've got 40,991.1. For option 2, we change the rate and we change the number of years. Okay, so we go to 3.5% for 6 years. We're going to come back in here. We're going to say 6. We're going to say 3.5. Okay, and that's going to give us 6,754.18. So we're going to come down here, 6,754.18. And we're going to multiply that by how many years? 6, because it says for 6 years, right? So we get 40,525.08. Which one was the cheaper option? Option 2. Okay. Does that make sense? Questions, comments, concerns? Okay. Looking at the last one, it's talking about how much a car payment is. You've got to pay attention to whether it says monthly or yearly. Okay. So you have the following expenses related to your car. Here it is. How much is your monthly expense for vehicle ownership? Okay. So if it said per year, what are we going to do with that one? So looking at maintenance, divide by 12. So what's 400 divided by 12? Okay, so 33.33. Again, the 75 is per year, so we're going to divide it by 12. What do you get? Okay, the rest of them are all in months. So what you're going to do is you're going to add 510 plus 475 plus 33.33 plus 200 plus 625 plus 50. Add that up. What'd you get? I got 1,274.48. You right. 1,274.58. Okay. So his monthly expense is 1,274.58 for his car. So it sucks. Pretty bad, right? How much does the average American make in a month? In a month. Like the average American makes approximately $4,949 a month. Now, you are paying $1,274 just to drive your car a month. But think about, you've got your house payment or your rent, which is normally between $1,500 to $3,000.
Which one would be more, transportation or having your own car?
Well, this is having your own car. This is upkeeping your car.
Would transportation be one?
Like, are you talking about like bus?
Yeah.
It depends, because now having a car makes time less. Bus, you would have to like get up earlier, be on the bus longer. It takes longer to like get to and from. So you got to look at, is your time worth your money, or vice versa. Okay, that's a good question. All right, looking at the other document. Go ahead and take a look at the other document. Go ahead and take a look at. Okay, a car that Jocelyn wants to buy costs $15,600. She does research and finds after 13 years, the car depreciates to a value of 0. If the car depreciates in a straight line form, find the depreciation line equation. So what is this going to look like? How much are we going to drop each year if we're going to drop to 0 in 13 years? How do we figure that out? Divide. Okay, good. Okay, so 15,600 divided by 13 gives me what? 1,200. Okay, so here's how you write your equation. Remember, it's y equals mx plus b. We're going to lose 1,200 each year. What's our y-intercept? How much did we start with? Okay, 15,600. Okay, here's our equation. Boom. If I got it, it's on your quiz. Like if you did 15,600, yeah, I'll take that. As long as it's not attached to an x, then that's wrong. Okay, John's car is worth $10,000 after 6 years. When the car was new, it was sold for $22,000. What was the depreciation rate? So when it was new, it's 22,000. We're going to lose 1 minus, we don't know what the R is because that's what we're looking for. We're doing it for 6 years, and it was equal to 10,000 after 6 years. Okay, now I don't want you to have to do any math. So what do I tell you to do? Desmos. Okay, so we go into Desmos, type it in. Yes. So we're going to say 1 minus x, raise it to the 6, equals 10,000. Now here's the question. There's 2 lines here, right? Well, there's 2 right here, right? Am I crazy? Nope. Okay, so yes. Okay, so where does it cross this x-axis? .12123. 0.123. Okay, so we're saying that R could be 0.123. Let's look at our other line where it crosses the x-axis. Yeah, why did we get more than one line? Oh, Lord, it won't go over. Come on. Right here, if we zoom in, that's going to give us 0.1877. Okay, so it could be 0.1877, right? Now, here's the deal. What you can do is you can plug in those rates and then just see which one works. So is that 10,000? It's close, right? What if we plug in? That's not close at all. So what should we put? I put about 12.3%. Yes. I give you a little bit of space to do some error. So like if you said 12 to 13%, I'd give you that. Yeah. So I plugged it back in to make sure it works. So like if I plugged in 0.123, raise it to the 6th power, I should get about 10,000. Yeah. Okay. All right, looking at number 3. A car that Sonia wants to buy costs $21,000. If she does research and finds that after 15 years, the car depreciates to a value of 0. If the car depreciates in a straight line, find the value that the car depreciates every year. So we're 21,000. How many years is that going to take? Okay, so how much? 1,400. And all it said was find the value that the car depreciates each year. Yep. Good. The first one was asking for you guys. It says find the straight line depreciation equation. So it's finding the equation. And then this one says find the value that it depreciates by. Hey, what's up? Yes. Okay. So you've got to read that ending so that you know which one it's dealing with. Okay. We want to do the extra credit one?
Yeah.
Okay, so Nathan wants to buy a car that costs $25,920. He has $3,000 as a down payment, and his payments will be $450 for 6 years. Did I skip? I did. You're right. All right. Nina's car exponentially depreciates at a rate of 7% per year. If Nina bought the car when it was 6 years old for $12,000, what was the original price? So how do we set this up? Remember, our formula is A times 1 minus R raised to the T, right? So when we plug stuff in, we've got 7%, so that's going to be 0.07 for my rate. 6 years old, that's going to be my time. And now it's 12,000, right? So we've got 12,000 equals, we don't know what the initial value is, 1 minus 0.07 raised to the 6th power. Okay, I don't like to have to solve. So what am I going to do? Desmos. Okay, so I'm going to type in 12,000 equals, instead of A, I'm going to put X. 1 minus 0.07. We're going to raise it to the 6th power. And then we're going to zoom out to see where it crosses the x-axis. Where are you at? Now this one's going to be a little trickier just because it's a bigger number. But you're going to use your x value. So we got 18,547.42. Do you see where I got that from? 18,547.42. Good. Why did I put the X instead of an A? Right. So if I put A, it's going to say create a slider. And that's not what you want to do. You put X so that you can look at where it crosses the X axis. Now, another way you could have done this, if you didn't want to do the graphing way, you could have taken what's inside the parentheses and divided 12,000 by it. So watch this. You take this and look at that. It got us the same answer. Okay. Again, that's solving the equation versus actually graphing it and it solving it for you. We okay? Okay. All right, I'm going to give